Hey, what's up, everyone? So this is Kareem from Mathemagic, and today I'd like to do an IGCSE paper walkthrough. So I know there's a lot of you out there who are about to have IGCSE marks, and some of the questions towards the end are really important to get right. So you should look at this paper like the beginning is something that's like a give me, and you should have like the first 10 to 15 questions down without any issues. And then the questions at the end are what are going to make the difference between like a grade 6 or grade 8 or grade 9. And so, of course, we want to go for maximum marks and we want to do our best. So I'm going to do my best to do this paper without going too fast and taking clear steps and giving you good techniques for you guys and girls to follow. So without any further ado, I shall try and do that with you and share screen. So I've loaded a paper up for you guys, which is from, let's see, which edition is this? This is the higher tier from 206, paper 3H. So I'll do a few of these, but this is the first one. And so we're going to get started. You have your formulas at the front, the sine rule, cosine rule, and some area formulas. And yeah, so we're going to take it from there. All right, so the first question is a bearing question, and the bearing is the angle clockwise from the north. So here we should be concerned with the north of A. So from A, so I'm going to draw an angle clockwise from the north, and you should probably be using a protractor here. I would recommend in the real exam that you draw this line down to show your teacher that you understand that this is 180, and then you'll be using this protractor here. This looks like something that's a little bit bigger than 90. I'm not too sure what this is going to be, but we could say, for example, 101 degrees perhaps here. So for your final answer, actually, you shouldn't write 101, you should do 180 here. If this is 101, then this looks like an angle of perhaps 281. Okay, so the bearing of another point C from A is 226. So from the north of A, I should have a point that's 226 degrees away. Now, if I think about 226, it's a little bit less than 270, but a little bit more than 180. So I should again take my line, and perhaps it looks a little bit like this, like almost like 45 away. So it'll be a 46-degree angle here from my 180. And the point is labeled C. So work out the bearing of A from C. Well, I need to figure out what the north of C is. So I'm going to do this line straight up, which is going to be the north of C. So this is the north. And I need to figure out the bearing of A from C. So I'm looking at the angle clockwise from the north of C. And this angle is 46 because it's alternate interior to this one. The two lines to the north are parallel. So this looks like it's 46 degrees. And so we should be happy with the first two questions. Make sure that you use a protractor here. I just randomly put the value 101. I'm not super happy with that, but there's nothing I can do on the computer. I don't have access to a protractor. Okay, so rectangular tiles here in question 2 have width x and height x plus 7. Okay, so some of these tiles are used to form a shape. The shape is 6 tiles wide and 4 tiles high. Write down an expression for x for the width and height. So the width should be 6 times x. So I'm just going to say that, 6x. And then the height, well, how many do I have? I have 1, 2, 3, 4. So I could say 4 times x plus 7. So 4 times x plus 7. And the next, so this gives me 2 marks. The width and the height of this shape are equal. So this is a square. So you're given the fact that this is a square. Write down the equation in x. So you'll say 6x is equal to 4 times x plus 7. No need to do anything else here. And then solve your equation and find the value of x. So next step. So I guess the interesting thing here is to realize that you need to expand the bracket. So you'll say 6x equals 4x plus 28. I'm going to move the 4x to the left, so plus becomes minus. So 6x minus 4x is equal to 28, which gives me 2x is 28. And to finish my question, I need to move the 2 to the other side. Times becomes divide. X is equal to 28 divided by 2, which is actually 14. And this is worth 4 marks. I could double check by plugging in 14 here. So 14 and then 14 plus 7 is 21. So this would suggest that this is 21 times 4, which is 84. And this is 14 times 1, 2, 3, 4, 5, 6, which is also going to give me 84. So that seems correct since it's a square. Okay, Andrea's Cafe, delicious cakes, only $4 each. Okay, cool. So she buys 100 cakes to sell in her cafe. She pays $100.80 for each cake. So she's selling cakes. And you can see right away that if she buys them for $1.80 and she sells them for $4, she's making a profit of $2.20. So without really looking at the question, I'm thinking the profit is $2.20. On Monday, she sells 60 cakes. She sells these for $4 each. Okay, so she's made that profit. And then she reduces on Tuesday the price of each cake by 1/5. So what's $4 minus 1/5 of $4? Well, $4. So essentially, she's selling them at 4/5 of $4 because she's reducing them by 1/5. So I say 4 times 4/5 is 16/5. So that's going to be the price of her cake, which if you're to reduce back to decimals is $3.20. She sells 35 cakes at this reduced price. Andrea then gives away the 5 unsold cakes. Calculate the total profit that Andrea made on the cakes. Well, okay, so let's take this in order. First, she made some profit with the first, so she had 100 cakes. She sold 60, so she made a profit of $2.20 on 60 cakes. So the profit is equal to $2.20 times the 60 cakes. And then she sells 35 cakes at $3.20. Now, if she buys them at $1.80 and sells at $3.20, you can easily see that 180, so 180 plus 140 is going to be equal to $3.20. So she's made a profit of $1.40 here. So she's still in profit with those next 35 cakes. So 140 times, let's see, 35. And then we have 5 unsold cakes. Well, these count for something because the problem with those 5 cakes is they're costing her money. So we need to think that there's 5 cakes. So take away 5 cakes that she's actually lost $1.80 on. Because she's just bought them for $1.80 and she's just lost that money. So I'm going to perhaps use my calculator here because I want to make sure I don't make a boo-boo. So 220 times 60 is $132 that she makes here. And then 140 times 35, 1.4 times 35 is another $49 profit. So we see her profit is a lot less with this, but that's okay. And then she's lost 5 times 180, which is $9. So I don't need a calculator for that. So 132 plus 40 is, so 49 minus 9 is 40, is actually $172. So she still made $172. And that's my total profit. So I could write that in the box here, 172, and I get 6 marks for that. Okay, great. So far we're doing good. There are 5 classes in a school. There's a pie chart. Okay, so let's remember that the pie chart, the circle adds up to 360. The pie chart is accurately drawn. So that means, again, I need a protractor, and I should have a protractor, and I don't here. So this is a little bit of a problem. Find the probability that this student is in class E. So what I'd like to measure arbitrarily is perhaps this angle. Let's estimate that this is 30 degrees. If that was 30 degrees, this should be 150 degrees. And we should do, for the probability, 150 divided by 360. So probability of E is equal to 150 over 360, which would be, if I use my calculator, 150 over 360. Again, this is a protracted question, about 41%. So 41.66, so 41.67. So I'll always round it up to 2 decimal places unless told otherwise. And I'm saying it's not exactly equal, but approximately equal. So that's good for 2 marks. The table shows information about the ages of students. Give an estimate of the mean age. Okay, so the average age of these students, and I have to give my answer to 3 significant figures. So there are 30 students between 9 and 11 years old. So I don't know if they're 9 years old, or if they're 10 years old, or if they're 10 and a half years old. So the best that I can do here to find, and the key word here is estimate, is to say, okay, well, I'm going to take the midpoint here, which is 10, and I'm going to do 10 times 30, which is 300. I'm going to do the same here. I'm going to take the midpoint, which is 12. 12 times 12 students is going to be 144. So these are years, right? There's 144 years between these 12 students. And then 14 times 18. Now, there are techniques to calculate this. You could say it's 256 minus 4 is 252. But just to be sure, I'm just going to use my calculator. 14 times 18 is 252. If you'd like to learn more about midpoint multiplication, you can refer to my video about how to multiply numbers like these. And then 15 times, so 17 here times 60. Okay, so again, I'm going to use my calculator to make sure that I don't make any errors. 1,020. So that's 1,020. And now I need to figure out the average age of all these students. So it's 300 plus 144 plus 252 plus 1,020, which is 1,716. It's worth double checking this number. And I need to know how many students I have. So how many students do I have? I have 30, 12, 18, and 60. Well, 12 plus 18 is 30. 30 and 30 is 60. 60 and 60 is 120 students. So I have 120 students. So I need to do the total number of students divided by how many students I have. So it'll be 1716 divided by 120. And if I type that in my calculator, the average age is 14.3. And that's exactly 3 significant figures. Remember, significant figures are numbers that mean something. This is an estimate. It's not an exact value, but it's good enough. So we took the midpoints. That's what you should know here. The number of workers in a factory decreases from 60 to 48. Okay, so 60 to 48, that's minus 12 workers. And okay, so what am I going to do with my 12 workers? A percentage decrease. So it's 12 out of the original number. So the percentage decrease is going to be 12 over 60, and 12 divided by 60. I can use my calculator, or I can feel comfortable with the fact that this is 0.2. So I can say that it's minus 20% here. So I'll say minus 20%, and the percentage decrease, I say 20%. So that's okay. That's 3 marks. So far, so good. Rajesh and Goody share some money in the ratio 2 to 5. Rajesh receives 240. So this is interesting. The first person gets 240. You could figure out what a unit is. So 240 represents the ratio 2. So 240 divided by 2 means a single unit of that ratio is 120 pounds. So work out the amount of that Goody receives. So if 1 unit is 120 pounds, Goody receives 5 units. So we can do 5 times 120, which is 600 pounds. And you can think that the first person gets 240 and Goody gets 600 pounds. Okay, 2 marks for that. Solve the inequality 9x minus 2 smaller than 5x plus 4. Okay, well, what I could do here is I could say I move the 5x to the left and the negative 2 to the right. I just have to be a bit careful with the less than equal sign. It's exactly the same as an equation, but if I multiply or divide by -1, I need to change the sign of the inequality. This is not going to happen here. So I do 9x minus 5x is smaller than 2 plus 4. And I get 4x is smaller than 6. And then x is smaller than 6 over 4. X is smaller than 3 halves. So that's it. x is smaller than 3/2. That should get me 4 marks. No, 3 marks. Okay. All right, 4 girls run in a race. Well, probabilities always add up to 1. So probably Danielle, the skill here. So 0.5, 0.6, 0.9. Danielle will be 0.1. So that all of this adds up to 1. So there's a 10% chance that Danielle wins, and there's a 30% chance that Karis wins. So there's a 0.4, there's a 40% chance that either of them win. So you need to make sure that you add up these two here to get another easy 3 marks. These 3 marks are so easy, so good. Okay, ABC is a triangle. I noticed that there's a right angle here, so that's good. I also noticed that 13 is there and this is 5. So if I know my Pythagorean triples, I should know that this is the 5, 12, 13 triangle. But without knowing them, then I probably have to use Pythagoras theorem. So Pythagorean triples, which you could know about, are going to be the 3, 4, 5 triangle or the 5, 12, 13 triangle, and any of the multiples of these triangles. So if you see like 6, 8, you know the hypotenuse should be 10 because it's a similar triangle to 3, 4, 5. And here I saw 5 and 13 and I thought, okay, well, this should be 12. We can check that that's true, however. The length of AM, so you should say, start with the hypotenuse, you say AC squared equals AM squared plus MC squared. And then AC squared is 169 because that's 13 squared. AM squared is 144. And then MC squared, oh no, wait, I'm looking for AM squared. I shouldn't know that it's 144. This is what I'm looking for. So I know that because of triples, but I should not know that. So AM squared plus 25. I'm going to move the 25 to the left to say 169 minus 25 equals AM squared. And I can say 144 equals AM squared. And you can see that indeed plus or minus 12 should be AM. However, AM is a length and a length can only be positive. So it's 12. Don't forget that when you have squared, you should have plus or minus. In this case, it doesn't apply. Part B, a solid has 5 faces. And notice that it's part B. And so notice that you already know, you already know from part A. When you see a part B to a question, you should always think that part A is relevant. So it's saying that it's similar to the triangles from earlier. So you know this is 12 and you know this is 5. And you need the total surface area. So this solid is split into triangles and it's also split into a square base at the bottom. So the area of the square is 10 times 10, which is 100 cm squared. And then the area of the triangle, well, you can say it's base times height divided by 2. So the base is 10, the height is 12 divided by 2. So that's the same as 10 times 6, which is 60 cm squared. Now, how many triangles do we have? Oh, well, we have 4. So the surface area is equal to 4 area of triangles plus the area of the square. So 4 times 60 is 240. The area of the square is 100. So this should be 340 cm squared. Okay, so we're happy with that. That was worth 4 marks. Reflect triangle P in the y-axis. Okay, so for reflection, I like to work with corner to corner. So I'm just going to take this corner to this corner. And then I'm going to take this corner to this corner. And then I'm going to take the last corner to the last corner. It's a bit tricky because I'm writing on a line that I've already drawn. And that should give me a decent triangle, which I'm going to draw in a different color perhaps so that I don't make a boo-boo. So that's my reflection here. That's 1, that's 2. And then my last line is going to be here, 3. Okay, so I'm pretty happy with that. So that's part 1. And to give triangle Q, so I should label it, I should say, okay, this is Q. Rotate triangle Q about the origin, so about here. And I need to rotate it 90 degrees clockwise. So clockwise is this way around. To give triangle R, okay, well, no problem. Again, I'll use corner to corner. So perhaps I'll use different colored lines. So I'll do this line here. And I need to figure out a line that's 90 degrees to this. So I should be doing another line like this to showcase that this is a 90-degree angle, because I have to do a 90-degree rotation. And I'm going to do this with all three corners. So here's another corner, and this you can see goes 3 across. So I'm going to go in the middle here, corner to corner. And then my last corner is up here. It's getting a little bit messy at this point. But let's see, perhaps this one goes 4 across down there. And I'm again going to use another color line to show my triangle, perhaps green. And if I connect the points, I should have something that looks a little bit like this. And I should be happy with that one. And this one I'm going to label R. Okay, so I've done the first bit. So I always use this corner to corner method. Describe fully the single transformation that maps P into R. So we notice that P, you have 4 basic transformations. You have enlargements, and the P did not get bigger when it became R, so that's not it. Rotations, well, yeah, you could definitely say that it's a rotation about center O, but it seems like it's reflected itself. But it doesn't look like a reflection that's completely straightforward. It looks like it's a reflection about this diagonal line here, which I can draw as, let's see, perhaps I draw it in purple. If I was to draw this line here, this whole big line here, that looks like a line of symmetry from P to R. And I can check that indeed it is, you know, corner to corner, all these points are getting mapped. So the skill here is to say that this is the line y equals x, like you have to recognize your linear equations, and you can say reflection about the line. So about the line y equals x. Oops, so I'm probably going to write this here so that I don't mess with the Zoom call. And that's it. That gets you 4 marks. So a little bit of construction work and a reflection. Okay, good. So far we're doing well. There's 15 students in class A. The students gain these marks, find the interquartile range. Okay, so the first thing I notice is that I have 15 marks, but they're written in the wrong order. So my job here is to reorder them. So how many 1s do I have? I have 1. How many 2s? I have 2, 2. Do I have any other 2s? Another 2 here. Any more 2s? No, that's it. And how many 3s? Oh, I don't think I have any 3s. How many 4s? No 4s. How many 5s? 1, 2, 3, 4, 5. So I'm just going to say 5, 5, 5, 5, 5. How many 6s? 1, 2, 3, 4. 1, 2, 3, 4. And then how many 7s? Single 7 here. And then how many 8s? None. And how many 9s? 1. I have to check that this is 15. These are 15 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I'm pretty happy that I haven't messed anything up. And I'm just going to look for a quarter of 15. Or 0.25 times 15. Well, a quarter of 16 is 4, so a quarter of 15 is 3.75. And I have to look for 3/4 of 15. So 3/4 times 15. And 3 times 15 is 45. At this point, I can do 45 divided by 4, which is 11.25. And there's a little bit of a trick here when you do interquartile range, is you must always round up. So I'm always going to do that. I'm always going to round up. So this becomes the 4th number, and this becomes the 12th number. And this is the 1st quartile, and this is the 3rd quartile. So yeah, instead of finding the 3rd number or the 11th number, you have to find the 4th and the 12th. So be careful with that. You always round up for quartiles. So let's do that. 1, 2, 3, 4. This is Q1. And then Q3 is going to be, so 15, 14, 13, 12. This is Q1 and Q3. Q1, Q3. Okay, so the interquartile range, IQR, equals Q3 minus Q1. So Q3 minus Q1, which in this case is 12, minus 4, which is 8. So I'm going to make my 8 a little bit less wonky, but there's my 8. And I'll take my pen back here. Okay, so let's see, what am I going to do next? So 8 should get me some good marks. The students in the B class took the same test. Their marks had a median of 7 and an interquartile range of 2. So the median is 7, the IQR is 2. So 2 comparisons. So if the median is 7, well, here the median is the number in the middle, which is 5. It looks like the median is so it's 15 students. It's the 8th number, right? So 4, 5, 6, 7, 8. This is the median here. So the 8th value. So the median in class A is higher. So you just say that the median in class A, the median in class A is 5, which is higher than B, because B has 2. And then you say the interquartile range in, so it was 8 before and now it's 2. In class A is 8, which is larger than B. So what does that indicate? It indicates that the values are more spread out in class A than in class B. So this indicates a larger spread in class A. So if you like, the marks in class B are more bunched up together. So a larger spread, because the interquartile range is a measure of spread in class A. Now, you may not need to say that, but just to make sure that you don't lose any marks, you should say it. All right, 2 points, P and Q, with coordinates 0, -4, and 4, 4. So 0, negative, okay, they're written out for us. The straight line that goes through them. So it's nice when you're asked to find the equation of a line to just draw it out. So there it is, I got lucky here. So we see that the y-intercept is -4, and then we need to find the gradient. So the gradient is the rise over the run. So I can figure out my rise here. dy is equal to 2, the run dx is equal to 1. So I go across by 1 when I go up by 2. So rise over run, or the differences in y divided by the differences in x is equal to 2 over 1, which is 2. And the y-intercept is -4. So I can happily say that it's y equals 2x minus 4. On the grid, draw the line with equation -1/2x plus 1. Okay, -1/2x plus 1. So it goes through 1 here, and it's got a gradient of -1/2. So it's going down. Let's see if I can do this a little bit better here. I can't do that. So perhaps what I should do is I should do this. There you go. So that I go through the points. So I should go down by 1 when I go across by 2. Of course, if I draw the line, I should label it -1/2x plus 1. So I label my line. So I've got 2 lines. They happen to be perpendicular. I can see that because the product of the gradients is -1. Okay, that's it. That's it for that one. That's 7 marks. So familiarize with yourself with linear equations if you weren't too sure how to do that. Okay, so cool questions here coming up. So 2 to the -3, negative means flip it. This is 1 over 2 cubed, which is 1 over 8. This means cube root, it's a fractional power, so 3 over 7. This means the 4th root doesn't mean that I can do, oh no, wait, this is the square root of 3 over 8. So this is the same as 3 over 8 squared. So one of the squares cancels out with the square root, and this becomes 9 over 64. So my answers are 1 over 8, 3 over 7, and 9 over 64. Okay, so so far so good, still happy. I think right now I'm getting close to a 9. Differentiation question. Okay, so now we're asked to find the derivative of y equals 5000x minus 625x squared So the derivative dy dx is going to be 5,000 minus, so I dropped the 2 in front, so 1,250x. So that's it, 5,000 minus 1,250x. Find the coordinates of the turning point on the graph. So that happens when y dashed is equal to 0. So therefore, 5,000x minus 625x squared. Oh, well, actually, no. I need to use the derivative. 5,000. This is the coordinate function. I'm using the derivative function. So minus 1,250x is equal to 0. So 5,000 equals 1,250x. Then 5,000 divided by 1,250 is equal to x. So the x coordinate is 4. So when x is equal to 4, I need to figure out the y coordinate. Well, the coordinate function is given to you up here. So I can do f of 4 is equal to 5,000 times 4 minus 625 times 4 squared. And that should give me the y value. So what's 5,000 times 4? That's 20,000, but I can do that on my calculator. 5,000 times 4 minus 625 times 16 is 10,000. So by plugging the 4 into the original equation, I get the y coordinate. And that's what you should do when you have the x coordinate and you're looking for the y coordinate. You just use the coordinate function. So 4 and then 10,000. Okay, state whether it's a maximum or minimum. Well, you could look at this quadratic equation and realize that because it's a negative x squared type of equation, like it's facing down, because it is minus 625 x squared here, which is a negative coefficient in front of x squared. You could say because of that, it's a maximum. So maximum. You could also look at the second derivative and show that the second derivative is negative. So you could say if y double dashed of x is negative, we have a maximum. And y double dash, the second derivative, let's see what it is, just for the sake of it. It'll be, so we take the first derivative and we differentiate again. So we get negative 1,250 equals f dashed of x. So the second derivative, f double dash, sorry. And because the second derivative is negative, which is negative, therefore it's a maximum. So either you think about the fact that the function is quadratic with a negative coefficient, so it's a sad face quadratic, and therefore it's a maximum point, because that's the only turning point. Or you do the derivative twice, and the second derivative is a representation of maximum, minimum, or point of inflection. I think a lot of students at IGCSE level wouldn't be too sure with that, so I'd recommend you use the quadratic. A publisher has to set the price for a new book. The profit depends on the price of the book. What price would you advise the publisher to set for the book? Well, probably £4. If you were at £4, then that would be the maximum profit. £4 is the maximum profit. So you make a profit of 10,000. Yeah. Price of the book, X pounds, the profit. So £4 suggests the profit of 10,000. Okay, you could say, which is 10,000. Maxi-cool, the new ice cream sensation. Okay, there's a hemisphere, radius, height of the cone, total volume of ice cream. Okay, so we have a hemisphere. So the volume of a sphere is 4/3 of pi r cubed. The radius here is 3. So we're going to say 4/3 pi times 3 cubed, which is 27. 27 divided by 3 is 9. 9 times 4 is 36. So it's 36 pi. And the volume of a hemisphere is half of that, so is 18 pi. Okay, so this is 18 pi cm cubed. And then the height of the cone is 10. So the volume of a cone is the area of a circle times a third of the height. So the volume of the cone is the area of a circle. So it's a third of the height times pi r squared. And here the radius is 3. So a third of 9. Well, I'm just going to write it out for you guys. A third times 9 times the height, which is 10 times pi. And a third of 9 is 3. 3 times 10 is 30. So 30 pi's cm cubed. And so the total volume, is equal to 30 pi's plus 36 pi's, which is 66 pi cm cubed. Now, of course, you'd like to give your answer to 3SF. So we're going to type 66 pi in our calculator, and we get 207.34. So I get approximately 207.34. And 3 numbers that mean something, so 3 significant figures. I'm just going to say 207. The 0 is in between the 2 and the 7. So the 0 is significant. It actually means something. If you have a 0 at the beginning or at the end, it's not so significant. But because it's nested in between, the 2 is in the hundreds, the 0 is in the tens place, and the 7 is in the units place. So these are 3 numbers that mean something. Okay, so we're happy. We should be getting close to the end, so thank you for your attention so far, and I really hope this is useful as you're revising. Choose a statement from the box that describes the relationship between A and B. You can see that B is a proper subset of A, like B is completely included inside of A. So this means A belongs to B, B belongs to A and the union of A and B is the universe. The intersection of A and B is 0. The intersection of A and B is A. Well, in this case, B is a subset of A. So this is my statement. B belongs to A. So I made a little mistake there. I was about to write element, but a subset needs to have this set notation here. So C is saying B is a subset of A. Here we see that A and B have no elements in common. So we're going to say the intersection of A and B is equal to the empty set. There's nothing that A and B have in common. So it's that one. That's a relatively nice question for question 16. Function f is defined as x over x minus 1. What's f of 3? So I'll plug that in. So 3 over 3 minus 1, which is 3 over 2. F of negative 3. So that's negative 3 over negative 3 minus 1, which is negative 3 over negative 4, which is 3/4. And then which values must be excluded from the domain of x? Well, I cannot have the denominator equal to 0. So x minus 1 has to be different from 0. So x cannot be 1. If x is 1, we have a 0 divider, and that's no good. So we say 1 is no good. And then f of x, so that means I plug f into f. So f of x is x over x minus 1. And if I was to plug that into itself, f of x, I could say it's f of x over f of x minus 1. And then now I need to do a little bit of algebra here. So I can say it's x over x minus 1 over x over x minus 1 minus 1. And I probably need to put the denominator on a x minus 1 denominator here. So I'm going to keep the numerator the same. And I have a quadruple sandwich fraction here. So I'm going to say x minus, and then minus x minus 1 becomes minus x plus 1 all over x minus 1. Oof. So I'm going to rewrite this as x over x minus 1 divided by 1 over x minus 1. So realize here what I did is I put them on the same denominator. I changed the 1 into x minus 1 over x minus 1. And then I applied the negative to it. So it became minus x plus 1. So the minus got distributed to everybody. And here I need to change my divide into a times. So this becomes x over x minus 1 times x minus 1 over 1. And the x minus 1s can cancel out. So I'm just left with x over 1, which is x. Now, a bit of an insightful answer to part C. If you plug a function into its inverse, you should get x. So if you do f times f to the negative 1 of x, you should get x. And if you do f to the minus 1 into f of x, you should get x. Oh, I wrote 0 instead of writing x, sorry. So if you plug a function into its inverse, you should get x. However, here we plug the function into itself. So we did f of f and we just got x. So this suggests that this function is its own inverse. So this is what we call a self-inverse function. It means that when you plug it into itself, you get x. So this function inverses itself, which is kind of crazy. It means that the original and the inverse functions are the same. I could graph this on Desmos to see what that means. Essentially, it means that both the graphs of the original and the inverse functions are symmetrical about the line y equals x. So y equals x is the axis of symmetry between the inverse and the original. I suggest that you do a little bit of work on inverse functions here to understand exactly what this means here. Solve the simultaneous equations. I realize this is the intersection of a straight line and a parabola. Most likely, I'll make them equal to each other and solve the quadratic. So I'll say x squared equals 2x plus 15. So I'll say x squared minus 2x minus 15 equals 0. I'll look for factors of 15, like 3 and 5. And lucky for me, I get x minus 5 factor of x plus 3, which means that my solutions are x1 equals negative 3 and x2 equal 5. And for those values, y is going to be equal to negative 3 squared, which is 9, and y is equal to 25. So I have these two solutions here. So negative 3, 9, or 5, 25. And these should be, again, you can use Desmos and graph x squared and graph 2x plus 15 and figure out that they intersect at these 2 points. Or use your GDC. You can use your graphic calculator. We should be getting close to the end. Each student in a group plays at least one of hockey, tennis, and football. 10 students play hockey only. All right. 9 students play football only, so I can stick that here. 13 play tennis only. Okay. 6 play hockey and football, but not tennis. Hockey and football, but not tennis. Oh, so there's 6 here. 7 play hockey and tennis. So this is interesting because those 7, that's inclusive of the x here. So I'm not going to write that down yet. 8 play football and tennis. So actually this is 8 minus x, and this should be 7 minus x. So we have to be a little bit careful here. Yeah. And x play all 3 sports. Okay, because the 7 represents hockey and tennis inclusive of x here. Write down an expression in terms of x for the number of students who play hockey and tennis, but not football. Hockey and tennis, but not football. Oh, I think I just did 7 minus x. Okay. There are 50 students in the group. Find the value of x. So all of this adds up to 50. So I just need to add it up nicely. So 10 plus 6 plus x plus 7 minus x plus 13 plus 8 minus x plus 9 equal 50. I'm trying to make a nice 50 here at the end. Okay, 10 plus 6, I got 7 and 13 here. That's a nice 20. So I get 16 plus 20, x minus x cancels out. And then 8 and 9 is 17 minus x equal 50. So let's see, 16 plus 20 is 36. 36 plus 17, 53, right? That's a bit odd. I hope I didn't make a boo-boo. I might have to backtrack here. 53 minus x equal 50. Oh no, I guess we're good because I'm going to move the x to the right. So I'm going to say 53 minus 50 is equal to x. and then I'll get x equal 3. And that's worth 4 marks. So all I did is add everything up and make sure that I put the x's with the x's. There's 2 negative x's which cancel out with the x here, and then all the numbers add up to 53, and then that's good. All right, so question 20. The ratio of the areas of 2 similar triangles is 1 to k. Write down in terms of k the ratio of the lengths. So if this is the ratio of the areas, 1 to k, the ratio of the lengths, you have to be a little bit careful. This means a few things. In terms of k, I should say it's 1 to root k, because the ratio of the, so I'm going to say this, the scale factor is the square root of the area factor. So if you have a scale factor, you need to square it to get an area factor. And if you have a scale factor, you need to cube it to get a volume factor. So in this case, yeah, I square rooted because I'm given the area factor. So let's see. AB is 10, BQ is parallel. So that we have similar triangles here. The area of, so I'm not sure if this is related to the first question, but anyway, I'll assume that it might be. Area of APQ, so area of APQ equals half of area of ABC, which means that the lengths, so let's be careful here. So the scale, the area factor, so the area factor is equal to a half, which means that one triangle is a half of the other, okay? Now, the scale factor is equal to a square root of a half. So that's the scale factor. Calculate the length of AP. Well, that's interesting. So if I go from the big triangle to the small one, I multiply by a half. If I go from the small one to the big one, I divide by a half. I have 10, which is the length of the big one. So I need to do 10 times the scale factor, which I do on my calculator, 10 times the square root of 1/2. So the square root of a half. I can write square root 0.5 in my calculator, that's okay. 10 times square root of 0.5, I get 7.07, 7.07. And here you have to be careful because correct to 2 significant figures, I need to say 7 point something, and the 0 gets rounded to a 1. So I'm going to say 7.1 cm, and I can say here 2 SF. So what I did here is I worked out the area factor, which was a half. And so therefore the scale factor is the square root of a half. Next question. A third of the people in a club are men. The number of men in the club is n. So n represents a third of the people, is a third of people. And then these are the men. So men equals n. Okay. Write down an expression in terms of n for the number of people in the club. Oh, actually, no, the number of men in the club is n. Yeah. For the number of people in the club. So then, it seems like a third is equal to n, right? So I'm a little bit confused here. Let's say the number of people in the club, should I call it something different, like n equals the number of people in the club, and then n times a third is equal to the number of men, which is little n, right? For the number of people in the club. So I can say the number of people in the club, big N, is equal to 3 times the number of men. So 3n. So there'll be 3 times as many men in the club as, yeah. So, okay. So there's big N is the number of people, and then little n is the number of men in the club. 2 of the people are chosen at random. The probability that both are men is 1/10. Okay, so what's the chance of picking out a guy? Well, there's the chance of picking out a guy is, so probability of man. So first I have to pick out a guy, which is 3n people over the number of people. Oh, actually, the number of men is little n, sorry. So little n over the number of people in the club, which is big N. And then after that, I have to multiply this by how many men I have now, which is n small n minus 1. And then there's one less person in the club, so big N minus 1. And that probability should be equal to 1 over 10. So I think I've got my equation now. I think what I need to do is change my big N into 3n so that I can figure out something which makes sense. So I'm going to use that substitution over there. Big N is 3n. So I could say n over 3n times n minus 1 over 3n minus 1 is equal to 1/10. Now n over 3 here, that's pretty nice. So I can say n divided by n is a third. I can move the 3 to the other side. So I could say n minus 1 over 3n minus 1 is equal to 3 over 10. And then these two n's have canceled out. So I just move the 3 to the other side and cancel these out. So divide becomes times. And then now I'm going to have to cross multiply. So I could say 10n minus 10 equals 9n minus 3. And if I move the 9n to the other side, I get n equals, and then if I move the minus 10 to this side, I get 7. So little n is 7. So that would suggest, oh, but I'm not looking for little n, I'm looking for the number of people in the club. So big N equals 3 times 7, so there should be 21 people. Well, let's see, if there are 21 people, is it true that a third of them are men? So 7 over 21, that would be a third. And if I did 7 over 21, and then I took 1 away, so then I had 6 out of 20, so a third times 6 over 20, it's worth checking because it's the last question and I have a bit of time. So let's see, what's a third times 6 over 20, that's equal to 1 over 10. So I know 100% that this is good. And so I'm happy. I can put that with a little tick mark, but I should use a green tick mark really. And I guess if you've got time to spare, then you should really look through your paper and go check that you're correct. This should get you 100 marks. If there are some marks missing, because maybe we made a little boo-boo somewhere, maybe you get 96, 97, but of course you should do a double check. This took us not a huge amount of time, less than an hour for sure, but of course, we're going through the paper with a relative speed and we're able to see the answers quite well. That's it. That's all you need to do to get a 9. I'll do a few more of these. Hopefully they're useful. If you have any questions or comments or there's something that will be helpful for you, then please let me know. Remember to follow our channel and to give us a like and subscribe. It's at Mathemagic MD. For Instagram or facebook.com/HL Mathemagic. And good luck with your IGCSE paper. Thank you so much. This was Kareem, and I'll see you next time. Bye-bye.